In this lesson, we're going to look at the area of a circle. How do you find the area of a circle? The approach I'll take with this is to introduce you to the radius and the diameter of a circle, show you the steps that I like to recommend to find the area of a circle, and then use those steps to walk through some examples together. So a radius of a circle is a line from the circumference, which is on the circle, not in the circle. The radius is the center in the circle to a point on the circle. So A to B is your radius. If you have another point right here, this is also A2, let's call this C, would also be your radius. Now your diameter is a line that joins one point on the circle to another point on the circle with an important note here. It has to pass through the center of the circle. So we can look at another way to look at this is that the diameter is the line that cuts the circle into two equal parts. That's another way to look at a diameter. Now, to get the area of a circle, I want you to understand that the area usually refers to the content inside an object. It's usually two-dimensional. When you're looking at three-dimensional, it's volume. But when you're looking at a two-dimensional object, for the most part, your area is inside. So right here is going to be our area. So you're looking at how much can this contain right in here. And so the area of a circle is pi r squared. Pi is a unique quantity that is used for circles. So pi r squared. The one thing to remember about a radius is going to be 1/2 of your diameter, or we can call the diameter divided by 2. And our area is pi r squared. We can also replace r with d over 2 for the diameter. So this is going to be pi multiplied by d over 2 squared, which is going to give us pi multiplied by d squared over 4. So that's how we come about this formula as well. So I like to stick with using the radius for area because diameter could be confusing until you become very, very proficient with circles. So the first thing I want to do here is I want to identify the radius of a circle. Then I'm going to substitute the radius into the equation A equal to pi r squared and then go ahead and compute. So let's look at some examples. What is the area of a circle with a radius of 14 centimeters? And it says let's leave our answers in terms of pi. So I'm going to I like to always start every math problem, if I know the equation, to write out the equation, pi r squared. So here, r is equal to 14 centimeters. So now our area is going to be pi multiplied by 14 centimeters squared. So our area is going to give us pi multiplied by 196 centimeters squared. So this is going to give me 196 pi centimeters squared. So the reason why we do it this way is because the question says leave our answers in terms of pi, which means leave pi in your answer. Next example, what is the area of a circle with a diameter of 42 centimeters? So let's say area is equal to pi r squared. So our radius right now is going to be diameter divided by 2, which is 42 centimeters divided by 2. And we're going to get 21 centimeters. So now we can substitute A equal to pi, and then we have 21 centimeters squared. So let's go ahead and find out what 21 squared is. 21 multiplied by 21. So we have 1, 2. We put a 0 right here. 2 multiplied by 2. 2 multiplied by 1 is 2. 2 multiplied by 2 is 4. So we put a 0 here. Add them. We have 1, 4, 4. Okay, 4, 4, 1. 441. So A is equal to pi multiplied by 441 centimeters squared. But here's an important note. We're told to just use pi equal to 3. So this is going to give us 3 multiplied by 441 square centimeters. So let's multiply this by 3. We have 3 here, 4 multiplied by 3, we have 12. We write 2, we bring 1 up here. 4 multiplied by 3, we have 12, and then we have 13. So our area is going to give us 1,323 square centimeters. Now, we're looking at some examples where we have the area, but we need to find the radius. So we always start still with A equal to pi r squared. So now our area here is 64 pi centimeters squared equal to pi r squared. So we have pi on both sides, so we can divide both sides by pi to get rid of pi. So we have 64 centimeters squared, or square centimeters, equal to r squared. Now, to find the value of the radius, we're going to find the square root of both sides right here. So the square root of r squared is r. Normally you would do the plus or minus. You have a plus or minus in front of the square root, but we don't need that because this is a length. Lengths can never be negative. So this is square root of 64 is 8. So our radius is 8 centimeters. Our final example, the area of a circle, we always start with our formula, pi r squared. One of the reasons why I like to always start with the formula is the more you write it, the more it becomes second nature. So you won't, I know in some classes, some teachers give you a cheat sheet with the formula, but I think if you actually solve through lots of problems and you're writing the formula several times, you get to a point where it becomes second nature. You don't have to memorize it, it just is there for you. And when you're having tests where those formulas are not available, you don't feel lost. So we have 25 pi centimeters squared equal to pi r squared. So we have pi on both sides. I can safely divide both sides by pi. So we have 25 centimeters squared equal to r squared. So now we need to first find the radius. So we take a square root of both sides. So we have r is equal to 5 centimeters. So our radius is 5 centimeters. What is our diameter? Our diameter is going to be radius times 2, because radius is diameter divided by 2. So our diameter now is 5 centimeters multiplied by 2. Going way ahead of myself here. Multiplied by 2. So this is going to give us 10 centimeters. So D is equal to 10 centimeters.